Welcome back to another edition of Alaska Weather Facts. I'm meteorologist Dave Snyder, and joining me once again is Eric Stevens from GINA, the Geographic Information Network of Alaska, based up at the University of Alaska Fairbanks. Eric, welcome back to the program.
Hey, I'm glad to be here.
And once again, you brought some wonderful satellite pictures to show us and do a little show and tell about. It's just amazing. I can get lost in satellite pictures all day. What did you bring today?
Right. Well, weather satellites, what are they good for? Yeah. Of course, there's the pretty pictures that they bring us. You know, we've got a picture here from April of 2012. Okay. The SUMI NPP satellite, it's what they call a polar orbiter, which means it covers Alaska because we're near the pole. Beautiful image. You can see a storm off of southeast Alaska, the sea ice along the Bering Sea up into the Arctic. A really nice picture, and this is important because it allows a forecaster to see where the storms are, where the ice is, where the clear areas are. You need to know where the weather is now if you're going to forecast it into the future.
Exactly.
So satellites give us these good pictures. This is called surveillance of the weather. And you know, that same satellite also has another picture from a little more recently, August of 2014, Tropical Storm Iselle bearing down on the Hawaiian Islands. Hawaii doesn't get hit by a whole lot of tropical storms or hurricanes. Sometimes it does. And here's a picture from the same satellite, the SUMI NPP Polar Orbiter. It shows Tropical Storm Iselle approaching the Hawaiian Islands from the southeast. You can see the storm swirling away there, and then there's the Hawaiian Islands. This is a tropical storm, not quite as strong as a hurricane because we don't see the eye wall in there. This is still a serious weather system. And all of this information comes just from that satellite picture. It's so much information, and it's wonderful to look at. You see the beauty and the awe of nature right there depicted in that weather satellite. We call it a polar orbiter because the satellite flies high over the globe. Maybe we could look here at we happen to bring the planet Earth with us. This is our satellite. A polar orbit flies really close to the Earth, maybe 800 kilometers over the Earth, and goes up over the pole and then back down, and then the Earth spins under the satellite as it goes by. That's in contrast to the geostationary birds, which are much further out. And they don't view Alaska quite as well. So we love those polar orbiter satellites here in Alaska.
So when we're a lot closer, we get much better details and imagery and an idea of a better maybe position of what's going on when it's passing right over Alaska or right over Hawaii.
Yes, exactly right. The polar orbiter gives such a good view of places like Alaska. And because it's close to the planet, there's another aspect of satellites in the polar orbit that is helpful for weather forecasting. It's an aspect that's maybe not as immediately obvious as the pretty pictures that we see. And that is the capacity for the satellite to produce what's called a sounding. That is finding the vertical profile of temperature and moisture in the atmosphere. We've all heard of weather balloons. Weather balloons are launched here in Alaska twice a day at a number of airports, everywhere from Barrow to St. Paul Island to Kodiak, Anchorage and Fairbanks, Yakutat, a number of places. Launch these balloons, and we've got a picture of a balloon being launched at an airport, and the balloon goes up. It's pulling a little package, an instrument package with it that reports temperature, pressure, humidity data back, and we use that information to help feed what are called numerical weather prediction models.
The models.
The models, right. It's a mouthful, so we just call it the models. And these computer simulations, these models, are computer programs that simulate the motion of the atmosphere. Well, how does a model know what the future will be like? You have to tell the model what things are like now. And you give it all kinds of information, including information from these satellite sounders. Very important. Just how important are they? We have a recent, comparatively recent study that really brings home, and this is Superstorm Sandy. We have a track image here of the track of Hurricane Sandy. It was down in the Caribbean around Cuba, and then it moved north over the ocean, offshore of the eastern seaboard, and then at the last minute, Sandy made what's called the left hook. It turned hard to the left and slammed into New Jersey. It was a major problem for the mid-Atlantic states, a calamity. It fused with another weather system and became known, this is not an official title, but Superstorm Sandy. It was quite the weather event. Well, the modelers, after the event, there's a group of modelers in Europe. They have a very good model, a frustratingly good model if you're the Americans trying to pursue their excellence. They reran their model afterwards in what's called a data denial study, where they kept everything the same. So this is 6 months after Sandy, but they went back, they reran the same model, they fed the model the same initial conditions, that is telling the model, okay, here's where we think Sandy is, down near Cuba in the Caribbean. Everything was the same as it was in the real forecast. except they didn't let the model know.
No satellite data.
No satellite data.
Okay.
So we're going to put that over here. No
Yeah.
satellite data for you. The resulting forecast 5 days out,
Yeah.
back when the real Sandy was happening and the model had the satellite data, the forecast was pretty good. We've got a graphic here on the left side. We show the forecast of where Sandy would be, and that's the red bullseye on the left. It's just south of where it actually wound up hitting. Not a bad forecast from this computer simulation, 120 hours out. On the right, you see the same model, but it didn't have the satellite data to help it understand things. And the storm is way offshore. It misses. The forecast is more accurate when the model has the satellite data. So that's the idea today we want to convey is weather satellites. They're important because they show us the pictures of where storms are. We see good examples of this. Yeah, the surveillance right now, it's great to look at those pictures. And in addition, behind the scenes, maybe not immediately obvious, but the models have to have that satellite data for them to be good forecasts. And then a meteorologist uses that information to help everyone with the forecast of where the storms will be in the future.
That is fascinating information that we can look at, see where things have been, because you can't know where you're going if you don't know where you've been. That's that old adage there. But seeing that satellites are actually helping us move forward in the weather information system is pretty amazing stuff.
You bet.
And if you want to check out Eric's satellite images that he's been talking about, whether that's something from today or last week or even much further back in Alaska history, you can easily do that yourself. Go to www.gina.alaska.edu and you can find those images there. Eric, thanks so much for joining us once again. And again, we will join you hopefully again soon for another edition of Alaska Weather Facts, where you'll tell us more really cool information about the satellites over our heads in Alaska. Thanks for joining us tonight, and we'll see you next time.